Okay, here's the solutions to the diagnostic test that you had for homework. Okay, in the first question you can see you've got a square root graph. There's a reflection at the front, and then it's moved 4 to the right, and then 5 down. So if I do a quick sketch, there's a reflection in the x-axis, so it used to be like that, and then becomes like this. And then if I go 4 to the right, I go there, there's 4. And then if I go 5 up, I'm here. So really what I've got is some sort of graph looking like that. Okay, so the domain should be pretty clear. You can see it starts from there and goes that way. It's 4, including 4 to infinity. And the range, well, the maximum value occurs up here, which is at 5. So the smallest value is going to be negative infinity to 5, including 5. Now the next graph, I'm not even going to draw it. You've just got a cubic. Okay, it's x, 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 so it's positive x with a negative at the front. It just looks like that. So it's kind of a trick question. The domain, maximal domain is real, and the range is real as well. Okay, there's no tricks to that. Okay, the next one here, might be a bit hard to see. Just look at your sheet. It's 2 to the e to the minus x. So you've got a dilation of 2 from the x, a reflection in the y-axis, and then up by 4. So the asymptote has been moved up by 4. The original graph looked like that, but now it's going to be reflected in the x-axis. Who cares about the rest? If I want the domain, it's just real, and the range is going to be 4 to infinity, not including 4 because that's an asymptote. Okay, next question. Now, marking those, each one's worth 1 mark. You must have the domain and the range correct for 1 mark. There's no half marks, guys. Okay, find the rule for the inverse. So you get 1 mark. It's got 2 marks only, charity mark for swapping. So as long as you've done this, you get 1 mark. Okay, secondly, or maybe I should write that as an e. Remember the base is e. You've got to translate it, but before you do that, you must remove the 1 and the 2. So if I add 1 to both sides and then divide both sides by 2, you'll be left with this. Okay, so it's log e that. Now I can translate it. You can only translate when the logarithm's got nothing at the front and nothing at the back. Okay, so base, e, logarithm or power gives us an answer of y plus 1. Almost there, you just have to subtract 2 to both sides. Now, I know this is a bit fiddly, but I'm not going to give you 1 mark, which will give you, that's the second mark, unless you've written it like that. It asks for the inverse, okay, so you've got to write it as f minus 1x. You can't write it as y. It's written as f of x there, so therefore you must write f minus 1x here. Okay, so the actual final function is this thing, take 1. Okay, e to the x plus 1, a bit hard to see, plus over 2 minus 1. Okay, next question. Okay, this one's really asking you about your rules. Find f of f inverse. Doesn't matter what those functions are, the rule is that that will always equal x. Okay, it's a rule. You can prove it, it'll be hard, but it'll make you cry. So that's the answer there. Okay, now we haven't done its domain. Now you have to remember your composition rules. So the domain, I'll just write it in short of, I guess you've got f of f minus 1, if it does exist, is the domain of f minus 1, the one on the inside, okay? That's on the inside. If it exists, that's the domain. And the domain of the inverse, well, we've got to go back up here, have a look at this function. If we quickly sketch that, you've got dilations, shifting left, right, who cares? The only thing that's important is it's not reflected in any sense. There's no negative at the front, there's no negative at the front of x, and it's just pushed down by 1. So if it's pushed down by 1, just see that graph there, it just means that you've got something looking like that. I don't care what it looks like. I just know that the range of that function is going to be from -1 to infinity. Doesn't equal -1. But I know that the range of that, the domain of that function is going to be actually all real. So sorry about that, I didn't need the range. If you go back to the graph, you can just see that it exists for all real values. Therefore, the domain of the inverses are done. Okay, next question. So sorry for 2 marks for that. All you needed to do was actually come up with the, it's pretty obvious, you just need to come up with x, but also r for the domain. Okay, 1 mark each. Okay, next question. Complete the square. Well, I really hope you got that right now. So g of x, I'm just going to break this in half, is equal to x plus 2 all squared. Now the last bit of that doesn't exist, so this would pump out a plus 4. So you subtract 4 and you've got plus 1 at the back. So g of x in turning point form would be x plus 2 all squared, take 4 plus 1 is take 3. Alright. Hence, find its maximal domain. Well, that was pretty obvious why they wrote it like that. Okay, you can find the turning point pretty quick. You went 2 to the left and 3 down, so negative 2, 3. It's a positive quadratic, so it looks something like that. I don't care about where it's going. I just need to find out what its domain and range are. So domain is everything. Okay, and the range begins here, which is at negative 3. Okay, it's negative 3 there. So it begins at negative 3, it can be negative 3, and then goes up forever and ever, positive direction. Okay, all right, write the rule for the inverse of g. So it doesn't ask for the inverse function, it just asks for the inverse. So just like the logarithm exponential relationship on the other page, you just need to swap. So the first, it's worth 2 marks here. Last question, sorry, you got 1 mark for writing this. Okay, so completing the square, 1 mark for the domain and 1 mark for the range. It was 3 marks, okay? Okay, the next questions. 1 mark, charity mark, just for swapping. Now, obviously, if you go back to the original, some of you might have done that, you might have got confused, okay? You have to complete the square or you can't actually find it. All right, let's rearrange that. Add 3 to both sides. So I've got y plus 2 all squared is that. Take the square root of both sides, so y plus 2 equals the square root of x plus 3. Okay, and you've got to remember the plus or minus. So the final function for the inverse, we've got to write it as g minus 1 equals plus or minus the square root of x plus 3 take 2. Okay, hope you can see that. I'll just change that focus a little bit. All right, but that's actually the answer there. Okay, now must write g minus 1x, but that's what you should have, plus minus. If you don't have plus minus, you don't get your mark, x plus 3 minus 2. Now the next question is kind of like, what the hell is going on, okay? Let's see if we can zoom in on it. All right, in this case here, it gets really crazy. You can't actually read it on my screen, but I'll just read it out to you and you can look at your sheet. Let the function h be the inverse function of g. So if we've got an inverse function, you need to realise that the original must be 1 to 1. Okay, so h is defined as this. Okay, so find the value of a so that h has a maximal domain and write the rule for h of x. Okay, so let h be the inverse function of g. All right. Now, as I look at that question, I've just realised I've made a mistake. My apologies. Okay, we'll talk about where the mistake is. But I have to make a big apology. Sorry guys, you're going to go home and look at it and then work out what's going on. What it actually should say is let the function h be the restricted function of g. Okay, so what I'm trying to talk about here is, it's a little typo. You've got negative 2 and negative 3 there. If we restrict this function, so if you restrict it to say like that, which is negative infinity to negative 2, so I'll just write that here. For that function, okay, so if you actually restrict that, okay, you'll make it 1 to 1, hence you can graph the inverse. So the next question underneath basically goes, right, now that you've got that function, then sketch the inverse. I think I might have to make a beeline for you guys before you actually go home on the weekend to make sure you get that right. So there's the original, negative 2, negative 3, it looks something like that. All right, negative 2 would be there, so if you want to do your line y equals x, looks something like that. All right, I need to find this point, so that's an x-intercept. So if you actually go back to the original function g, and it's up the top there, I'm just going to write it here, it's g of x is equal to x plus 2 all squared minus 3. Okay, so if I just actually let y equal 0, you'll find your x-intercepts. Put 3 on the other side. Take the square root, so I've got x is equal to, plus or minus root 3, take 2. So all I did was just take the square root of 3. There it is there. Remember, it's plus or minus, and then I've taken one more extra step. I've taken the 2 over. All right. Now, in this case, that was supposed to be this value here, and there's another value over here. The smaller one, if you look back here, must have been minus root 3, take 2. Okay. So in this case here, all you need to do is mark in that value. So that's minus root 3, take 2. Now in the inverse, that point just gets swapped around. So that's 0, sorry, it's minus 3, minus 2, 0. But now it becomes 0, minus root 3, take 2. So that's going to occur somewhere over here. So I've got minus root 3, take 2. Okay. This end point, which is actually negative 2, negative 3, has actually become negative 3, negative 2. So there it is there. They're going to intersect on the line y equals x. And gee, that could be done a bit better. Okay, but that's basically it. So there's an intersection point here on the line y equals x. That end point is negative 2, negative 3, becomes negative 3, negative 2 in that answer. Now this is a bit of a mess, isn't it? So some of you, I reckon, may have graphed the whole inverse here. Look, what I actually ask you to do is maybe just ignore this, okay? So when you're marking it, my apologies, I might just say take that question out before you go home for the weekend. But at least you can see what we've actually done there. Okay. I don't think I've ever got a diagnostic test correct there, have I? Now, next question, number 4. This is what's really important, isn't it? So in this question here, just can't get that in focus, can I? Okay, in this question here, what we've actually got is a trig function, so I'm just going to write it, sine of 2x is equal to 1/2. Okay, first thing you need to do is find the basic angle. Alright, so the basic angle in here is just going to be pi and 6. Alright, now we've got positive 1/2, so in the circle, the y coordinates are positive there and there. Okay, now the domain is 0 to pi. So we can write it like that, x to pi, and we're replacing it with the pretend domain of 2x, which becomes 2 pi. So really you're just going around your circle one whole lap. When you go around your circle one whole lap, you hit it here and here. This value here is just your basic angle, which is pi and 6. I'm just going to say 2x is pi and 6. And the other one is going to be pi minus pi and 6, which is 5 pi and 6. Okay. So they're the values for this angle, but obviously we don't want to work out the angle, we want to work out x, so x is just pi and 12 and 5 pi and 12. Okay, done. Now it's worth 2 marks, so we'll keep it simple. You get 1 mark for the basic angle identified, keep it really simple, and we'll just look for both answers. You must have both correct, okay? Next question. Solve for x in the following. So you've got tan of x equals 1 on root 3. I always just remember that, well, that would be this. Okay, so it's 1/2 over root 3. The sine value's on the top, and guess what? It's exactly the same as the one we've just done. So the basic angle is pi on 6. Okay. What we've got is a positive value for tan. So if you draw your circle, tan is positive in first and third. Okay. Now it's 0 to 2 pi, there's nothing tricky about it, so you just go around one whole lap. So the two values are going to be here, your basic angle is pi and 6. This one here is pi plus pi and 6, so that's 7 pi and 6. That's it. Okay, not hard at all. So x is going to be pi on 6 and 7 pi on 6. Now it couldn't all be too easy, could it? Okay, I had to give you a challenging one at the bottom. So in this case here, this one's very different. Now forget about that stuff in there. Okay, I know it's hard to see, just read your sheet. You know what I'm talking about, the stuff done to x. What you just need to simply go is just go, hey, the angle I needs to give us an exact value of 1/2. So what x coordinate gives us, what angle gives us an x coordinate of 1/2? Okay, the basic angle is the first thing to get. So the first thing you need to get is actually pi on 3. Okay. I forgot to mention in the last question, same again, basic angle 1 mark, and must have those both correct for 1 mark. Okay, so basic angle, this one's worth 3, this one's a little harder, okay, so basic angle is that. We're talking about being positive, so if you want to draw your circle, we're talking about first and fourth quadrant for cosine, or the x coordinate, okay. Now this thing is quite interesting here, so let's have a crack at trying to write a pretend domain. So the original domain is pi between 0 and pi. So we've got 2x there, so I'm going to multiply it by 2. So I get 2 pi 0, and then it says take pi on 2, so I'm going to subtract pi on 2. So subtracting pi on 2 I get 3 pi on 2, and subtracting pi on 2 I get minus pi on 2. That's not too bad. So maybe we'll just draw another circle. Okay, what I'm going to do is highlight the two cosine values that are involved. Now I'm going to break it up, remember, I'm going to go from 0 to 3 pi on 2, so there's this region here. And then I'm going to break up the other region going from 0 to minus pi on 2, so there's 0 to minus pi on 2. So interesting enough, it's really like one lap, but the angles are obviously different. So I actually hit here and here. This one is actually at our basic angle, which is pi on 3. The other one, remember I'm starting at 0, going around to the basic angle is minus pi on 3. So I actually only get two answers. So the two answers, I'm just going to write them down here. Now remember, this is for the angle, it's not actually for x. So 2x minus pi on 2 equals pi on 3 and minus pi on 3. Okay, just remember seeing it over here. Alright, now I have to tidy it up, so I have to add pi on 2. Oh, what a pain, you've got 2's and 3's. Have to turn them to 6's. So we'll turn this to 6's, so just double it. So that's positive and minus 2 on 6. Alright, so I'm going to add 3, that becomes minus 3 pi on 6. So I'm going to add 3 pi on 6, so that becomes 5 pi on 6. And add 3 to that, I get pi on 6. I have to divide both by 2. Okay, so I've got x is equal to 5 pi on 12 and pi on 12. Much trickier, that one. Okay, you get 1 mark for the final answers. You get 1 mark for writing pi on 3, and you get 1 mark for identifying the initial values of pi on 3 and minus pi on 3. Okay, you could have screwed it up from there. Alright, much more difficult, that one. That's as hard as they get. Okay, this is a long video, I know that, but we're almost finished. Okay, last couple of questions here. Find the value of x in the following. Now, this one here, I know you can't read it, but this is for real, so it's a general solution. Okay, so have your theory sheet handy if you've forgotten, but rearranging it quickly. Okay, this is the easy part. It's minus a half. So just do it like normal. Just pretend we're going from 0 to 2 pi. So the basic angle, so when do we get the x coordinate equal to a half? What angle it is? Okay, it's going to be pi on 3. Okay, the sign is negative, so cosine is negative in these two quadrants, in the second and the third. Okay, so what you just need to realise is you just need to identify that angle here, and you can see that if it's pi on 3, this becomes 2 pi on 3, and in this direction here it would become minus 2 pi on 3. Alright, so both those angles can be written as plus or minus 2 pi on 3. Alright, and then, like your formula says, whatever those basic angles are, you just have 2n pi next to it. Alright, so the basic angle is 2 pi on 3 plus or minus. You can see it this way. Going around that way you get 2 pi on 3, and going around this way you get minus 2 pi on 3. Alright, now don't forget, do not forget integer. Alright, so 2 marks. Let's keep it really simple, hey? 1 mark for the basic angle, and then that. Now I actually just forgot, sorry, apologies. You get 1 mark for that. You won't get anything for that actually, because that's actually 2x, isn't it? Alright, so you just have to divide everything by 2. So I'll just sneak it down here. X is actually, this will be n pi, and this will be plus or minus 2 pi on 6. Okay, so it's n pi plus or minus 2 pi on 6. Remember, people get confused about this. Remember, you're solving, that's not the angle. This is x, so it's different. Alright, so 1 mark for that, okay, and 1 mark for that. Pretty tough. Alright, last question. The extension kind of has fallen apart, but if you want to have a go at it, I'll show you how to do it as well. Okay, the transformations. So I might just rewrite it, because obviously you can't see it's in focus. Alright, who forgot to take everything out the front of x? Okay, first thing you should really do before you do anything is rewrite it, where you've got the factors out the front of x. Okay, so if I'm going to take out negative 2, that means I divide by negative 2, so that becomes negative 3 on 2 plus 1. Just check it. Well, that times that is negative 2x, that's good. That times that gives me positive 3, and that's what I got there, that's good. Now it's fine to work with. Now it's worth 3 marks, okay? It's a bit tough to give the marks here, but we'll give it a shot. The order, you must talk about this and this first. It doesn't matter about the order, but this and this must be discussed first. Okay, so as long as these as a group are done first before the upright and left, right, up, down, that's fine. So in this case here, you've got a dilation, I'll call this number 1, dilation of 2 from x. Okay, second, we've got a dilation of, I hope you got this right, a half from y, it's not 2. Okay, and then you can also put there reflect in y as well. Okay, I'm running out of space, I'm just going to go over this. Okay, and then the last step is just describing these. Again, it doesn't matter about the order, but as a packet they must be done after these things, okay? So then, number 3, we'll just talk about this guy. We've gone 3 on 2 to the right, and then lastly, 1 up. Alright, so it's worth 3 marks. Listen, we'll keep it simple. I'll give you 2 marks if you've actually described all of these, not in the right order, okay? If you've got all of these done correctly, meaning you've described all of them correct, but you might have got one of these in the wrong order, okay, just give yourself 3. For full marks, you must have all of them correct. Okay, not a great marking scheme, but sorry, it's out of 3, isn't it? So 1 mark, we'll give you 1 mark if you get 1 or 2 of these correct, okay? So this one could be correct, the rest could be wrong. This one could be correct, the rest could be wrong, whatever. Okay, that's 1 mark. Pretty much 1 mark for 2 up. 2 marks if you've got them all correct except 1. Okay, and 3 marks, they must all be correct. All right, not a great marking scheme, that'll do. Now the last question was actually finding the intersection of h and its inverse. Now it's very difficult to do, but especially when I haven't written it down correctly, so we might just leave it. Okay, it's a long video. I don't know if it's a great video, but I just hope that it's enough to give you feedback for that. All right, good luck with that. All right.